LeetCode questions 62 unique path. Basically, the question wants you to find the number of unique way to go from the starting points to the ending points. So, for example, you have a 1, 2, 3, 4 columns and 3 rows, and you are starting here. This is your start points, and this is your end points. So they want you to find how many unique paths they can get from the start from the end, such as this is counted as one path, this is counted as another path, right? So the restriction is that you can only move right or down, so it makes things much simpler. So which means that from at any positions you can only move right, either move right or either move down. Yeah, so I think many of you can have come up with solutions such that it takes about 2 to the power of m times n, right? 2 to the power of n times m, so that you can iterate, so that you can go from any points and see how it goes to the ends, something like that. So let's try with this brute force method first. Yeah. So you want to say you want to build functions called, just call chairer, and it taking the current positions ij, mn's, or I like to call it n and m, right? So nm, and we say if we reach the end, return 1. 1 is the count. So if I equal to m minus 1 and j equal to m minus 1, then return 1. Else if so if we didn't reach the end, we want to check if it's within the boundary. So if going out of boundary, return 0, because there's no way for you to go from anywhere such as outside the boundary to the finish point, because you can only walk within the any cell box. So if I is bigger or equal to n, or j is bigger or equal to m, then return 0. Otherwise, we simply walk. So move down or move right. So we say chairer, that count equal to 0. So count chairer I plus 1, j, and m. So here count chairer j plus 1 and m, and then we return the count. And from this point we return chairer from 0, 0 to n, m. Yeah, so let's test it. Oh, it gives us a correct answer. Oh, it gives us a correct value. So let's try submit. It takes a very long time to compose, and it will say TLE. Yeah, so which means our brute force solutions is not fast enough. So what is the optimization that we can do? Yeah, It's very obvious because for any of this cell, for example, we are at the positions here in the first row and fifth columns, we might not attend these positions once, we might attend it multiple times. Okay, using the first row is not a good example, maybe this row, second row, right? So we can go from here. So let's try this. So for example, we have a new box, 1, 2, 3, 4, 5. So how many times we need to attend these positions? Many times. We can go from here, we go from here, we go from here, right? 3 ways. So we need to run 3 times at these positions. But how many solutions do we have from this position to the end? We only have 1 and 2. For each time, we have repeatedly running through all these computations again and again, and this is a waste of resources. So what we need is actually a DP structure, any data structure to record our status. So if we have visited certain path and have compute the number of cows from that cell to the end, then we are no longer need to compute the same things again and again. We simply return the number of cows that we have computed before. So let's use the DP is equal to array dot n dot fill array n dot fill -1. Yeah, so initialize to -1, and we pass this DP in the functions. So we want to check if we have visited ij before. So if DP ij is not -1, then we'll return DP I and j. Otherwise, we'll run down and run right, and then we record the values before we return it, such as DP ij is equal to cow. Yeah, and then return a cow. So we also want to update our function call. Yeah, looks fine. So let's try. Okay, try more examples. Okay, let's submit. We passed. So let's do a time complexity analysis. So time. Since we only travel to each cell at most once, then it takes O n times m, right? For space complexity, how many space have you used? So we check for the DP, which costs us O n times m. What's the stack space? Stack space. So the longest stack space is from the beginnings to the end, which is about O n times m. So which means conclusions is still bounded by n times m, right? Because it's very obvious that n times m is smaller than n plus m. So you can simply ignore this, yeah, stack space. So this all for these sessions, and the source code of this submissions is provided in the GitHub link below, and for other LeetCode solutions that done in JavaScript or other languages can also found in the GitHub repo listed below. So that's all for today. Thank you.